Alternating current is defined as current that periodically changes direction and continuously changes in magnitude. Such current starts at zero and builds up to a maximum in one direction, then falls back to zero, builds up to a maximum in the opposite direction, and returns to zero. The values of alternating current and voltage can be indicated by using a sine curve. As shown in the illustration, this curve represents a definite voltage or current value for a certain degree of rotation through the alternating cycle. One cycle begins at 0 degrees and ends at 360 degrees. The value of the alternating current is 0 at 0 degrees, maximum in one direction, at 90 degrees, 0 at 180 degrees, maximum in the opposite direction, at 270 degrees, and 0 at 360 degrees. For practical purposes, the values of an alternating current may be considered to follow the sine curve. For example, a single loop of wire can be placed so that it rotates in a magnetic field. As the loop turns, the sides of the loop cut through the lines of force, and an EMF is induced in the sides of the loop. The illustration shows an alternating current sine curve and its relationship to an alternating current circuit supplying an alternating current machine. In the illustration, the side AB is moving up through the field, and the side CD is moving down through the field. The voltage induced in AB causes current to flow from A to B, and the voltage induced in CD causes current to flow from C to D. Such voltages add together and cause current to flow in the direction ABCD. Notice, this action takes place for as long as AB is moving up and CD is moving down. When the coil is in a vertical position, the sides are moving horizontally and parallel to the lines of force, and no voltage is induced. However, as the loop moves through this position, the side AB rotates down through the field, and the side CD rotates up. When current flow is connected to an external circuit by the action of slip rings, the current travels in one direction, while the loop rotates from 0 degrees to 180 degrees, and in the other direction, while the loop rotates from 180 degrees to 360 degrees. While in the vertical position, the loop is in either the 0 degree or 180 degree position, and no voltage is induced. When the loop rotates into the horizontal position, the maximum voltage is induced due to the sides cutting the greatest number lines of force. The alternating current sine curve is utilized to represent the values of voltage or current from 0 degrees to 360 degrees. The illustration shows how current flow is produced due to induced voltage from the field poles through the loop to the external circuit.